Well, near UVA rays, 405 indicates the wavelength of these rays, 405 nanometers. These are rays of the visible spectrum. So we are talking about photometry as distinct from radiometry, which is below 400 nanometers. Therefore, they are centered on the 405 nanometers. LEDs that are narrowly centered since they are below 400 nanometers with less energy. The visible light wavelength is between 400 and 780 nanometers. So they are visible and they have a color, ranges between violet and deep blue. How do they differ? They have both positive and negative characteristics. As everything else, there are pros and cons. In terms of reflection and transparency, they are significantly better than UVC rays that are universally known as disinfectant rays, and therefore lend themselves to applications where reflection and transparency can be harnessed even more easily. As all visible rays, they can even envelop rather than suffer from, at least to a lesser extent, the problem of shadows. They can certainly be managed more safely compared to UVC rays. Let's say that they are clearly safer. Near UVA ray management is a precautionary kind of management. As it happens when UV rays are used, you need to wear sun goggles when you tan or for similar things we know very well. Consequently, safety is better managed. Clearly, attention should be paid to particular subjects such as albinos or those with photosensitivity problems, etc. However, it is generally manageable. On the contrary, UVCs are more difficult to manage compared to near UVA rays. They are more effective from the electrical point of view, so they heat up less, to put it very simply. However, they have a slower disinfection dynamic compared with UVC rays. My colleague is more of an expert and will explain this question better. Yes, to put it very simply, one has to consider that the mechanisms of action used by 405 nanometer rays compared to the standard 255 nanometer light are largely different. The former, that is near UVA rays, act mainly on the stress they produce on microbes as well as viruses, while as far as UVC ray goes, basically their main mechanism of action is the alteration of microbial multiplication, and consequently, microbes are no longer able to self-replicate. A microbe that does not self-replicate is basically that it's not harmful to your health, at least as far as the environmental context is concerned. A couple of words on what Professor Cevenini has already mentioned about the management of near UVA rays, that it is made easier due to their very manageability. That is, whilst with UVC rays, one has to be particularly careful for potential risks for the eyes, for example, or also for the skin. Near UVA rays basically represent a frequency of light already present also in the sun. As we know, when one is intensely exposed to sunlight, there are no particular damages. Well, the action of the biocide is mainly exerted on structures in the case of near UVA rays and on replications, alterations in the case of UVC rays. These are the dominant mechanisms, and clearly there are some gray areas in reality where mechanisms overlap. But if we really had to schematize, I think it would be put down to what I have said.